Hello, and welcome to this Getting Started guide for the Tim Connect software for use with the Micro-Epsilon thermal imaging cameras. This video will help navigate the software for the first time and show you some of the basic features of Tim Connect. It is assumed you have the latest version installed, but if not, you can download it for free from our website. I will put a link in the description for you. The software itself does not require a camera connected to run and can be used to replay and analyze previously recorded files from one of our thermal cameras. However, for this video, I expect you will have one of the thermal imaging cameras connected. Once the software is installed, double-click the software icon to start the program. If you have your camera connected, the software, when opening, will attempt to connect to the camera and load the calibration files. If it's the first time you are using the thermal camera with the computer, then you will get a prompt to connect to the internet and download the files from our server. This is the best and quickest way of getting the calibration files. Alternatively, they will have been provided on a USB stick with the camera. So if you don't have an internet connection, you can install the calibration files from the USB drive. So once the software has the calibration files, it will then attempt to load them and then connect to the camera. So now what we have is the main software screen. We refer to this as our standard screen layout, which shows a main live thermal image from the camera along with various other blocks of information. It is also possible to change and save different layouts, but I will show you this later. First, let's take a little tour of what is currently on display. The main window shows a live thermal image from the connected camera. The number of pixels of the image will be determined by the camera you are using. In my case, I have a TIM40 camera connected, which has 382 pixels in the horizontal direction and 288 pixels in the vertical direction. Each pixel has a radiometric value, and as I move the cursor around the image, the temperature value of the pixel is being displayed. Also on the image is one of our measurement areas, Area 1, and this is currently defined as our main measurement area, looking for a maximum temperature within the rectangular area. This value is shown in the top right with an arrow to indicate that it is looking for the maximum. The area window value is also shown in the digital display group. This is on the far right, along with the cursor's position temperature when on the main image. Before we do anything else, it is important to ensure the camera is in focus so that you have sharp detail for correct temperature measurement of each pixel. Blurred pixels will report inaccurate temperatures. The method to focus the camera is dependent on the type of camera you have. The TIM160, QVGA, VGA, M1, M08 and M05 cameras have interchangeable lenses with manual focus on the lens itself. The TIM8, TIM40 and TIM41 images have an integrated lens with motorized focus adjustment made within the software. So let me show you that now. Use the distance icon to open the focus control. Use the slider to adjust the image focus to make the target sharp. Close the window when complete. Now we have a sharp image, we can continue the tour. The measurement area is currently set in the center of the screen and is providing a value of maximum pixel temperature. If we want to adjust the position or size of the area, we can do this by moving the cursor to a corner and simply click, hold and drag. If we want to move the whole window without resizing, we can do this by holding down the Control key on the keyboard while dragging the area. The reference bar shows the color temperature scale. Depending on the settings you have, this scale is automatically adjusting based on the temperatures in the image. Just below the main window, we have some adjustments for the color image scaling. 3 sigma uses the mean temperature of all the pixels plus 3 standard deviations of pixel spread above and below the mean to set the upper and lower limit. You can see this information in the histogram in the lower right section. We have a mean temperature of 24 degrees and a standard deviation of 2.4 degrees. So our color scaling on the reference bar is 24 plus or minus 3 times that standard deviation. Selecting 1 sigma tightens the color scale. The less than and greater than scales the color based on the highest and lowest pixel temperature within the image. With any of these settings, the color scale will change based on the pixel temperatures of the image. If you use the manual setting, you can fix the scale so that temperature changes of pixels no longer influence the color scaling. You can adjust the scale manually using the slider and the mouse. OPT stands for Optimization of the Color Palette to show greater definition between temperatures within the thermal image. Along the bottom of the screen is some information about the camera. You can see the type connected, the serial number, the type of optics in use, the temperature range currently set for the camera, the pixel coordinate of the cursor, the recording frame rate and display frame rate of the software, emissivity of the image, ambient temperature of the camera, and the status of the flag. The flag is used to control the temperature drift of pixels over time and is a mechanical shutter between the lens and the detector that periodically moves across and covers the detector. It then uses its own reflected image and known temperature to readjust for thermal changes. Also shown on the screen are 2 temperature profile lines for horizontal and vertical pixels. Think of these as a slice through the image. Currently they are not shown in the main image, but we can turn them on using the View, Image Information, and activate Temperature Profile 1 and Temperature Profile 2. You now have like a crosshair in the image, and again the position can be adjusted according to what you want to look at. What you have is a cross section of temperature wherever the profile line has been set. The final area is that of the temperature time diagram. This shows a history of the temperature against time for any measurement areas on the screen. If at any point you have closed an area, you can reactivate it using the toolbar icons at the top of the software. The colour palettes of the software are changeable using the forward and back to skip through the different palettes. The ones you choose are really dependent on the type of information you are looking to obtain from your process. To take a snapshot of the image, you click on the camera icon. You can choose in the Save File type the TIFF for the colorized image, a text which gives you the pixel information for every single pixel as a CSV file, or the temperature profile data of the single profile lines as we discussed earlier. To start a thermal video recording, use the record button. This will start the video recording, and once your process has finished, use the stop button. Select where you want to save the file and save. This will then replay the video you have just recorded. Now, interestingly here, the best thing about this is that we can still manipulate and change the window and the positions as we want on the video. So in practice, you only need to ensure that the camera is in focus and that you have the right temperature range defined before hitting the record button. To exit the video, just press the stop button. The camera image will then reload and you will be back to your live image. In my next video, I will show you how to use the configuration menu to add additional windows and set other functions and features of the Tim Connect software. Thank you for watching.